The speculation of an old tremendous blast is, all around, perceived by most experts as the major clarification for the starting points of the universe, incorporating the production of stars, planets, and all life, including us. Regardless of its to some degree complex name, the expression huge explosion appropriately catches the extent of the occasion. At first, the universe was a thick assortment of particles compacted into a space more modest than a pinhead. Starting here, a titanic blast of issue happened, known as the enormous detonation. This compactly sums up the cycle that unfurled more than billions of years. However, no matter what the getting through fame of the speculation of how things became, progresses in logical information have constantly tested its forecasts. At the point when NASA sent off the James Webb Space Telescope, the biggest and most progressive space observatory to date, specialists guessed that its perceptions would uphold the theory of how things came to be. Sadly, after only 1 year in space, the telescope has bewildered researchers with its momentous capacities, giving uncommon experiences into the universe's past. The James Webb Telescope's discoveries have uncovered frameworks so antiquated that they might actually reshape how we decipher the universe's starting points. This surprising disclosure has started huge interest among researchers and fans the same. One such indispensable disclosure came when space expert Rohan Natu, examining early pictures from the James Webb Telescope, inadvertently tracked down a framework that shocked everybody. This cosmic system, named Galaxies 13, gave off an impression of being strangely monstrous and traced all the way back to only a brief time frame after the enormous detonation, making it more seasoned than any recently noticed world. Nada's energy was unmistakable as he imparted the disclosure to partners, portraying it as past whatever stargazers might have ever imagined. The James Webb Telescope, arranged a long way from standard obstruction and outfitted with cutting-edge innovation, was expected to dive into the universe's earliest age, known as the grandiose first light. This period, covered in secret, denotes the development of the universe's most memorable stars and worlds. By inspecting frameworks from this period, researchers desire to refine how they might interpret principal grandiose cycles, for example, the effect of issue and dull energy. Initial assumptions for the James Webb Telescope's disclosures were unobtrusive, expecting only a couple of far-off universes. Nonetheless, reality surpassed all projections. The telescope's pictures uncovered frameworks of shocking intricacy, testing existing models and inciting a whirlwind of exploration. As examiners keep on analyzing the James Webb Telescope's information, the ramifications of these discoveries could be significant, proclaiming another time of cosmological comprehension. The momentous disclosures from this basic observatory offer an enticing look into the universe's past, driving mankind's mission to unwind the privileged insights of existence. As early frameworks arose, scientists and onlookers ended up scrambling to figure out them. Might this social occasion of curiously huge and brilliant early systems at some point be an oddity, maybe because of defects in the telescope's underlying estimations? Or on the other hand, if valid, might they at any point some way or another be accommodated with standard cosmological models? Conceivably, they were the principal signs that the universe is more abnormal and more intricate than our boldest hypotheses had expected. The inquiry isn't anything not as much as how we decipher how the very universe we know rose up out of early chaos. The early discoveries from the James Webb Space Telescope might actually reshape the fundamental parts of enormous history. These parts concern far-off ages in faraway frameworks as well as our own presence here in the smooth manner. As Imprint McCaffrian, a senior counselor for science and investigation at the European Space Organization engaged with JWST, commented, "You construct these machines not to affirm the view, however to break it. You simply don't have the foggiest idea how it will break." In a way, JWST's perspective on early worlds has been billions of years really taking shape. However, more unpretentiously, they follow back to the Space Telescope Science Establishment in 1985. Around then, the Hubble Space Telescope was still a long time from send-off. By and by, the organization's then chief, Riccardo Giacconi, requested that his group begin pondering what could come after Hubble, something considerably more far off. In spite of beginning discussions over zeroing in on Hubble, Giacconi was tenacious, expecting the long improvement process. Garth Illingworth, then delegate overseer of STSCI, alongside a little group, started drafting thoughts for what at last turned into the cutting-edge space telescope, later renamed JWST. They understood that while Hubble would be earth-shattering, its capacities would be restricted by its perceptions in noticeable light. The NGST, then again, would see in the infrared reach, permitting it to peer further into the universe. The requirement for JWST turned out to be significantly more obvious in December 1995, when stargazers directed the Hubble Profound Field Perception. Notwithstanding assumptions for finding a couple of weak worlds, the subsequent picture uncovered a great many cosmic systems extending back north of 12 billion years into the universe's history. After over 20 years of improvement and at an expense of around $10 billion, JWST was at last sent off on Christmas Day, 2021. The telescope went through thorough testing prior to arriving at its last space objective a month after the fact. By July 2022, it was prepared to start its enthusiastically anticipated first year of logical perceptions, known as Cycle 1. A piece of JWST's underlying mission was given to high-influence programs, including the Vast Development Early Delivery Science Study and the GTO Huge Early Science Program, both pointed toward giving bits of knowledge into the secrets of the early universe to space experts devoted incalculable hours to checking separate patches of the sky, looking for early grandiose frameworks. They at first expected humble revelations, maybe a more nitty-gritty rendition of the Hubble Profound Field. Nonetheless, they were in for a shock. Stephen Finkelstein from the College of Texas at Austin, driving the SEWERS project, noticed that such far-off frameworks were supposed to arise solely after different information cycles from different projects. However, surprisingly, these worlds seemed rapidly. Previously, the record for the most far-off realized framework had a place with GNZ 11, SAW in 2015 with a redshift of 11. Redshift estimates the extending of light because of the universe's development, with a higher worth demonstrating more noteworthy distance. Yet, toward the beginning of glass perceptions, two separate groups, including one drove by Rohan Natu, freely recognized glass Z13 with a redshift of 13, pushing the timetable back fundamentally further. In their scramble for fast outcomes, specialists depended on worked-on techniques for redshift assessment in light of brilliance estimations as opposed to additional tedious direct assessments. Despite their effortlessness, these strategies uncovered worlds startlingly splendid and huge, some previously showing a heavenly mass moving toward a billion suns, like our own. The energy didn't stop there. Before long, numerous cosmic system competitors from SEWERS and GLASS arose, some with redshift gauges as high as 20, recommending they existed only a brief time frame after the enormous detonation. These worlds showed circle-like designs not anticipated in such early grandiose ages. Besides, another group tracked down proof of winding designs at a redshift of 10, under 500 million years after the enormous bang. Such fast development of sizable systems challenges the suspicions of the standard cosmological model, lambda cold dim matter, lambda CDM. To comprehend this peculiarity, a concise revisitation of early universe elements is fundamental. In the underlying minutes after the huge explosion, the universe was a hot, thick soup of early-stage particles. Over the long haul, as the universe extended and cooled, helium and other light components shaped, prompting the making of the main particles. Around 400,000 years after the fact, roughly 100 million years after the enormous detonation, conditions became good for the arrangement of the primary stars, made principally out of hydrogen and helium. These early stars, bigger and more brilliant than current stars, congregated into proto-worlds, directed by the gravitational draw of dim matter. However, JWST's revelations challenge this model, as it uncovers stunningly enormous inestimable frameworks far sooner than anticipated. Stacy McGaugh from Case Western Save College noticed the astonishing absence of various more modest protocosmic parts, proposing that a few noticed frameworks may be nearer than anticipated, clouded by dust, seeming dimmer and more far off. The revelation of early systems brings up critical issues about the universe's beginnings, featuring the requirement for proceeded with exploration and refinement of our cosmological models. Follow-up perceptions of glass Z13 in August 2022 by the Atacama Enormous Millimeter Exhibit, ALMA, in Chile cast uncertainty on the underlying discoveries. Regardless of the utilization of splendor-based gauges, ALMA didn't recognize critical measures of residue related with glass Z13. As Pascal Oesch from Geneva College, who drove the perceptions, noticed, this proposes that low redshift frauds can be precluded. However, ALMA attempted to identify the cosmic system without success. This features the test of affirming discoveries made utilizing JWST's high capacities. Rohan Natu, one of the scientists in question, called attention to the incongruity of the circumstance, expressing, "The uplifting news is there's nothing identified." He proceeded, "The terrible news is there's nothing distinguished." meaning JWST is equipped for circling back to its own perceptions. The most disturbing clarification could be that the standard lambda CDM cosmological model,